Okay, time for some proofs. We are going to use the side angle side congruence theorem to prove that two triangles are congruent. This is really similar to what we did on the other page, this page right here, but these weren't proofs. They were close, we kind of explained some of our reasoning, but they're not exactly a formal proof, and so that's what we're going to do here. Okay, there's three big ideas from the previous page that I want to make sure that you remember as you're going through this. Okay, the first one is reflexive prop of equality. Okay, you can use the reflexive property of equality to say that a line or a segment is congruent to itself if two triangles are sharing that side. Okay, so that's a big one. You're going to see that all the time. Okay, the next one that's really important is the alternate interior angles theorem. Okay, look for parallel lines. If you have parallel lines cut by a transversal, you get triangles, kind of. Right? So look in this one. Remember parallel lines cut by a transversal? If you just connect the shape a little bit, you get some triangles in there. Okay, so alternate interior angles theorem is another theorem that's going to help you get extra information, or a piece that you can use to get more information. Okay, the other one that you're going to use quite a bit is the vertical angles theorem. Okay, vertical angles will also give you more congruent angles. So use those three, look for those three, look for ways that you can use those three in the proofs. Each one of the next proofs, 9, 10, and 11 in this section, each of them is going to use one of these at least. So you're going to have one that uses vertical angles, you're going to have one that uses reflexive property at least. You're actually probably going to use this more than once. And then you're going to have one that uses alternate interior angles theorem. So just like the previous page, that's the reasoning. That's going to set you up for these guys. Okay? Another thing that you want to look for is like definitions that you can use. So let's take a look at number 9, and I'll help you get started on this one. Okay, in number 9, you have PQ, right, is a line, bisects angle SPT. Okay, keyword. What does bisect mean? It means cut in half. Cut in half into two equal pieces. So if you cut something in half into two equal pieces, what do you get? You get two congruent pieces. In this case, we're talking about an angle bisector. So if a line cuts an angle in half, it cuts that angle into two congruent pieces. So this idea, bisects right here, is really important because it's basically giving us another angle. Okay, so SPT is this guy, SPT. So this is an angle. And this guy, PQ, cuts that angle in half, which is why this guy and this guy are marked congruent. Now, the figure doesn't even have to give you that marking. That's kind of a bonus. It's kind of helping you out. So let's say it didn't have that marking. You would actually go in and put that marking there yourself because you know that bisect means cuts into two congruent angles. Okay, so we're going to use that definition. That's another idea that's important. Also, we know that SP is congruent to TP. Okay, so they're marked congruent. Awesome. So they already did the work of marking the figure for us, but if they didn't, we would go in and do those markings for ourselves. So let's start off with the given. Okay, so we got PQ bisects angle SPT, and also the line segment SP, or the side of that triangle, is congruent to TP. Okay? Now we want to show that these two triangles are congruent, right? Let's go ahead and write our last line here, and hopefully we have enough space. Sometimes I don't count. Or actually, let me put it down here, just so I have as many lines as I may need. So SP is congruent to TPQ. Okay? How are we going to get there? Well, we know we're going to try to use SAS. So if we can prove that, our last justification will be that this side angle side congruence theorem. So we want to prove these two are congruent. We want to do it by side angle side congruence theorem. We know where we're started. We know where we're headed. We just got to fill in the middle. Okay. So let's talk about this. What we can say now is that angle SPQ, this one right here, SPQ, it's this guy, is congruent to angle TPQ. TPQ. How do we know that? Because PQ is a bisector, right? It cuts these into two equal angles. And so we're going to say this is the definition of angle bisector. That's how we know they're congruent. PQ cuts this big angle into two little guys that are congruent. Okay, that's what a bisector does. All right, we already know this. We also know that PQ is congruent to PQ. Right? This guy is congruent to itself because these two triangles that we're talking about, they're sharing that side. Right? So we know they have a congruent side because they're sharing that side. So PQ is congruent to PQ. How do we know that? We know that by the reflexive prop of congruence. Any segment is congruent to itself. Any angle is congruent to itself, right? Reflexive is like reflection, like when you look in the mirror and you see yourself, right? So this guy, it's like an image of itself, okay? Reflexive property. So think mirror. Okay. And we're pretty much there. We actually don't need any more lines, but so we have SAS, right? We already have stated, there's your S, there's your A, there's your other S, right? So if you're going to use SAS, you should see a line for S and a line for A and a line for S. You should have all those proven. So once we have SAS, cool, we're good. We can just say SAS. So I actually didn't need all these lines. We're going to jump from this guy to this guy. So when you're doing this, you can rewrite it if you want, but there we go. That goes there. Cool. Okay, I'm going to get you started on the other ones, and I'm going to let you finish them. Okay? So what you should notice here, that's really important, is parallel. Right? So I'm going to give you a line. You're going to put it in the proof somewhere. But we know angle 1 is congruent to angle 2. Okay, how do we know that? Well, let me turn it real quick. This might be a little bit more what we're familiar with. Okay, so remember, these little tick marks indicate congruent. The arrows indicate parallel. So I'm going to extend these parallel lines out so we can see something that we're more used to seeing. And I'm going to extend this guy out, which is like a transversal. Two parallel lines cut by a transversal gives us congruent alternate interior angles. And these guys are alternate interior. They're on opposite sides of the transversal. They're on opposite lines, right? This is our transversal. So angle 1 is congruent to angle 2 by alternate interior angles theorem. Okay, that's the key. So you know where to start. You're starting here. Okay, you know where to end. You're ending here. You know even what the justification for this last step is. It's going to be SAS, of course, side angle side congruence. You just got to state how you're getting your sides. One of them is given to you. There's side 1. How are you going to get your angles? Boom. How are you going to get your third side? It's that one. It's very similar to up here. These two triangles are sharing this side. Alright, so that's going to give you your side angle side. So you're going to finish writing up that proof. Okay. Okay, number 11. Again, I'm going to introduce it to you, and you're gonna finish writing it. So you should hopefully be getting better at writing proofs at this point. All right, C is the midpoint of A, E, and BD. So again, they kind of give us a bonus because they actually labeled this figure for us, which is kind of nice. So what does midpoint mean? Midpoint means it's in the middle, right? Which means that the segments on either side of that midpoint have to be congruent because the middle is halfway between. So this is a half and this is a half. So a midpoint is kind of like an angle bisector or a segment bisector. Midpoint is going to cut in half or separate into halves. Okay? So what you get is 2 congruent segments when you have a midpoint. Okay, now CE is actually saying that it's the midpoint of two segments, right? So let's break this down. C is the midpoint of AE. Okay, well here's AE. If C is the midpoint of AE, then that means that AC is congruent to CE. Now they gave us the markings, so we already kind of know that, but the reason why we know they're congruent is because in the given it says C is the midpoint. So if we didn't have those markings, we would go, oh, C's the midpoint? Cool. Well, let's go in and label that congruent to that because it's in the middle. C's in the middle. Okay. By similar logic, if we look at the other segment, C is also the midpoint of BD, right? So C is halfway in between BD, which means that this segment has to be congruent to this segment because that's halfway in the middle. So here's one half congruent to the half on the other side. So midpoint, like bisector, is like a ding, 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 ding. I just gave you congruent figure, or I just gave you congruent shapes, right? Angle bisector is going to give you two congruent angles. Midpoint is going to give you two congruent segments, okay? So that's kind of the key there. So let me help you get started. So we're going to say C is, I'm going to use MP for midpoint of segment AE and BD. Given. Okay, what does that mean? Well, what it means is already labeled in the figure. It means that AC is congruent to EC. Okay, we also know that BC is congruent to DC. How do we know that? Definition of midpoint. That's what a midpoint is. It's a halfway point. So the two halves have to be equal. Okay, that makes sense, right? All right, so now we got side and side. We got two sides. What we need is the included angle. We need this to be congruent to this. Can you get there? Can we say these two angles are congruent? The answer is yes, we can. Let's be specific. Now we know that like A corresponds to E because these guys are congruent. C is congruent to itself. So A corresponds to E and B corresponds to D. So when we write these segments, or these segments and these angles, the order is important. So angle ACB we don't want to say ACB is congruent to DCE, right? Because we're going from long to short. We don't want to go from short to long. So since A corresponds to E, A is in the first position, E needs to be in the first position. Then we go to C. C corresponds to itself, that's fine. And then B corresponds to D, because those are the two short sides. So B is in the third position, that means D has to be in the third position. So the order we write this is important. Why? How do we know? That's for you to find out. Once we have that, you can finish. Triangle ABC is congruent to triangle EDC. So come up with that justification. This one's obvious because it tells you in the instructions. This one we did on the first page, so you should know that. Okay, that should help you with the proofs. We're going to come back and do one more theorem and then use it